Today we're diving into something that feels like it's been ripped right out of a sci-fi novel. We're talking about teaching AI how to evolve.
I mean, just think about that question for a second. Can AI actually evolve like animals do? Can these digital things running on servers go through their own version of natural selection? It sounds pretty out there, but a wild new breakthrough suggests the answer is, yeah, kinda.
And here's the headline. Researchers literally taught AI models how to choose mates and create offspring. Now, obviously, this isn't biology, but they're using the exact same principles, combining traits from parents to create something brand new.
So the big question is, how on earth does this even work? Well, it all boils down to a new kind of AI genetics, a way for these models to recombine their own digital DNA.
The core concept here is called recombination, and it's a really smart idea. Instead of spending a ton of time and money building a new AI from scratch, you just take existing models, the parents, and you algorithmically merge their best parts to create a new offspring. And they do this genetic mixing in two clever ways. First, there's the parameter space. You can think of this like mixing the actual DNA of the parents, blending their core programming together. But then, there's the data flow space. This is more like deciding how the body gets built from that DNA. It changes the internal wiring and how information flows. When you combine both, you get an explosion of different possibilities in the offspring.
Okay, so making a bunch of new, varied AI models is one thing, but that's only half the battle, right? Just like in nature, you need a way to figure out which ones are actually good. You need survival of the fittest.
And that's where this beautifully simple loop comes in. It's a three-step dance. First, you generate a whole population of new models. Second, you put them to the test. You see how well they perform on a really specific job. And third, you pick the winners. The top performers get to become the parents for the next generation. You just rinse and repeat, and with each cycle, the AI population gets better and better adapted.
Sound familiar? It should. It's the core idea of Darwinian evolution. In this digital world, the environment is just the task you're testing the AI on. The models that are better adapted to that task are the ones that survive and get to reproduce. Now here's a really important point. The goal here isn't to create one single, all-powerful AI. Not at all. The goal is the opposite. It's all about specialization. It's about evolving models that are perfectly suited to one very specific job or ecological niche. And these niches can get incredibly specific. For instance, the researchers wanted an AI that was amazing at both Japanese language and math, or one that could understand images through the lens of Japanese culture. Think about it this way. They weren't trying to breed a lion, which is a general predator. They were trying to breed a snow leopard, an animal perfectly, exquisitely adapted to its unique mountain environment.
And this whole focus on specialization, well, it led to some results that are frankly pretty stunning. Because it proves that in AI, evolution can make models that are way better without just making them bigger.
So let's look at their evolved Japanese language model. It has just 7 billion parameters. Now that sounds huge, but in the world of giant AI models, 7 billion is actually kind of small fry. So just keep that number in your head for a second. 7 billion. Because what this little guy accomplished is incredible.
Check this out. This relatively small 7 billion parameter model went up against a massive 70 billion parameter model. That's 10 times its size, and the little guy won. On Japanese language tests, the smaller, specialized, evolved model actually scored higher. It's a total David versus Goliath story for AI.
And it's the perfect evolutionary analogy, right? It's like a nimble, specialized predator outcompeting a much larger, clumsier animal in its own backyard. Adaptation and efficiency beat brute force.
But this is where my mind really gets blown. The new, evolved models started developing abilities that neither of their parent models fully had. The new vision model, for example, suddenly got really good at understanding the unique meaning of Japanese traffic lights and other culturally specific things. These were totally new skills that emerged from the mix.
And you know, maybe the most practical benefit of all of this is just how efficient it is. Building these huge AI models from the ground up costs a fortune and uses a mind-boggling amount of computer power. This evolutionary method is so much smarter. It uses existing models as its genetic material. It's not creating from scratch, it's breeding. And that is a potential game changer.
So all of this leaves us with one final massive question.
Hundreds of millions of years ago, life on Earth went through the Cambrian explosion, a short period where life suddenly and rapidly diversified into countless new forms. If this new technique is the spark for AI's own Cambrian explosion, a sudden burst of diverse, specialized, evolving intelligences, what in the world comes next?